Well, we need to get those three statements, sides or angles of congruency to be able to prove these two triangles the same. So let's just start with the first thing they give us and see how far that gets us. So I have segment AB parallel to segment CD. So AB is parallel to segment CD. Okay, AB and CD are parallel. What's the transversal? Well, I could maybe use one of these up the side, but then I've got angles that, well, 2 and 4 together would make one of the angles, could get some consecutive interior. If I go down if I use the transversal down the middle, I think I get some alternate interior angles, but be careful. 2 and 3 are alternate interior, so are 1 and 4. But which of those pairs are the ones formed by the parallel lines? Because the only way I know both of those pairs of alternate interior angles are congruent is if both sets of lines are parallel. So you've got to make sure you know which ones. And if you look, the sides of angle 3, I have that highlighted right now. That's one of my parallel lines and my transversal. The sides of angle 2, that's my transversal. It's one of my parallel lines. But if you look at 1 and 4, one of the sides of 4 are a 1, and one of the sides of 4, they're not highlighted. I don't have those angles formed by parallel lines cut by transversal. So you cannot say angle 1 and 4 are congruent. Maybe we could prove them congruent, but we don't know that to start. So we can't use that information. All we can do is say from the parallel lines that angle 2 is congruent to angle 3. Those are alternate interior angles, alternate interior angle theorem. The angles are congruent. The theorems prove them congruent. Okay, that's one. That's a set of corresponding angles, right? If that was a, what is that, a reflection? No, that would have to be, for A would end up corresponding with C. Is that the way they named it? Does A correspond with C? And yep. And then B would rotate around to D. B rotates around to D. Okay, so it's a rotation. That would correspond. That's one set of corresponding angles. One down, couple to go. Okay, what's the next thing they give us? Actually, they just give us that. CB and AD, that's a set of corresponding, if it's rotated around, yeah, that's the set of corresponding sides. So in the given, we already had one. But that's it. That's all they gave me. So whatever else we look for, we've got to be able to get from our picture. So there's a few things. We've looked for linear pairs, vertical angles in our picture, when they share a side. If you have well, actually, in this particular case, they share a side. So what side do they share? Segment AC, right down that middle, is the same from both triangles. Now be careful. If this isn't a rotation, where does A end up when it gets rotated from one triangle to the next? Or where does C end up? So if you want to be correct and name these, remember when you name something that is congruent and corresponds, it's supposed to imply which points correspond and how they correspond. So by writing segment AC congruent to CA, I know that that's being rotated and those 2 points correspond in that way. And that will be a third set of sides. Hopefully this isn't a swear word because I've got the letters for it, so we'll have to double check that before we just finish. But it also could be side angle side, because the order we get it in our proof doesn't matter. It's the order in our picture that tells us which theorem is going to finish us off here. RPC. Something can be congruent to itself. Let's double check here. So I have, let's see, do I have side angle side? Is the angle that I have in between the two sides that I have? Actually, let me double check. It doesn't appear to be that way. I've got a couple opposite. The angle in between those two would be angle 4. This would be, if you wanted to get all the way, you've got that information, but I guess we'll just have to put a question mark here. So it's not that we don't know that they're it's not that we know they're not congruent. We just don't have enough information. Because that would be, I'll just say, no swearing. Yeah, that property, that's not one of our properties. Did we miss something? Are there vertical angles? No. Did we get the wrong angles from the parallel lines? A, B, C? No, I'm sure we got the right ones. That's just the way it goes sometimes. Ah, and you thought we were going to be able to prove them. I don't know for a fact that those two triangles are congruent. Look like it in the picture, but we just don't know for sure.